increasing and decreasing intervals. All right, so you might remember from pre-calculus, hopefully you do, my little diagram with my hiker guy climbing up the mountain, falling off the cliff, being revived, and then climbing back up again. All right, so you know then, so I've pre-drawn it here, we have our little hiker guy. So you should remember that since he's walking downhill, all right, since he's walking downhill, we know that the graph is decreasing where he's walking downhill. So for this entire interval from here to here, this graph is going to be decreasing the entire way. And then again, as he starts to go back uphill, from here all the way to here, this graph is going to be increasing now. All right, but at the very bottom, at the vertex of the polynomial, this is neither increasing nor decreasing. All right, neither increasing nor decreasing. All right, so since this is neither increasing nor decreasing, what that means is the slope is constant. The slope is constant, all right, and it is said to have no slope. Well, no, I'm writing slope again. It is said to have no slope, all right, or a slope of 0. All right, either no slope or slope of 0. All right, so anytime if you have a graph that is continuous and differentiable, you cannot go from increasing to decreasing or vice versa, as in this, because this goes from decreasing to increasing, without being constant somewhere in between. All right, and what that means is your slopes here, we know all of these slopes are negative. All these are going to be negative slopes. All right, because if you do draw a line tangent to all these points along here, they would all have negative slopes. Okay, similar here, they would all have positive slopes. All right, but here in the middle, it's neither negative nor positive, so it is a constant slope of 0. All right, so you can't go from decreasing to increasing without being constant somewhere in between. All right, so now here's your rules for increasing and decreasing. If f prime of x is less than 0 for any x value, then f of x is decreasing for that x. All right, likewise, if f of the prime of x is greater than 0 for any x, then f of x is increasing for that x. All right, and if f prime of x equals 0 for any x, then f of x is constant for that x value. All right, let's look at an example, because I know I always like numbers. All right, so let's say f of x is x squared. Let's list all of the increasing, decreasing, and constant intervals. All right, list all increasing, decreasing, or constant intervals. So step 1, we got to find f prime of x. All right, and f prime of x for this case is 2x. All right, step 2, we have to get the criticals. All right, so for this one, f prime being does not exist. So we need to find out where f prime of x equals 0. So take 2x, set it equal to 0. So x equals 0. All right, let me move this out of my way. So we got our criticals. Our critical is 0. All right, so step 3, draw a number line. All right, step 3 is draw a number line. So let's draw a number line. Here we go, number line. Let me move this down a little bit. All right, so now what you want to do is you want to plot your critical values, all right, that you just found. All right, and don't forget that this represents f prime of x, not f of x, f prime. So plot our criticals. In this case, we only have 0. All right, and then let's go to a point on either side. So 1 and -1. All right, and of course, I'm going to star this so we remember that's our critical value. So now what we want to do is we want to test a point to the left of our critical and to the right of our critical. All right, so let's test -1. Well, if we put -1 into 2x, we're going to get a negative number. So so that means that f prime of x is less than 0. So that means this side of our interval is going to be decreasing. All right, and this side of our interval, if we stick in 1, we're going to get a positive 2. So that means this side is going to be increasing. All right, and now don't forget to plug in your critical value of 0. If you plug in 0, we get 0. So at 0 is the only place where it is constant. All right, that's the only place where it's constant. So let's write our intervals. Our graph is increasing from 0 to positive infinity because it's increasing on this entire interval here, starting at 0 and going that way. Our interval is decreasing from negative infinity to 0. All right, so starting at 0 and going that way, it's decreasing. And now at 0, it is constant. All right, so it is constant at 0. All right, so little review, what you do to list the increasing, decreasing, and constant intervals. First thing you got to do is find f prime of x, which we did. In our case, it was 2x. Then you had to get your critical values. So where f prime does not exist or f prime equals 0. In our case, f prime equals does not exist is not going to exist in our case, so we don't have to worry about that. We can throw that one away. So what we have to worry about is where f prime equals 0. So we take 2x, set it equal to 0, solve for x. X is 0. That's our only critical point. So step 3 is draw a number line. So we drew a number line and plotted our critical point. I start it so we could keep track of it. Now we wanted to test a value on the left and test a value on the right and test the critical value to find out whether increasing, decreasing, or constant. So we put in the -1. -1 gave us a negative number, so therefore it's decreasing on the left side. We put in +1, it was a positive number, so it's increasing on the right side. We plugged in 0, and it kicked us out 0, so it's constant at 0. So our intervals are increasing from 0 to infinity, decreasing from negative infinity to 0, and it is constant at 0. All right. Now I want you to try. All right. I want you to list, and that's actually the wrong function. I don't want you to use that one. Let me cross that one out. Sorry. I want you to list all increasing, decreasing, and constant intervals for f of x equals x cubed minus 3 halves x squared. All right, so pause the video for a moment, a couple moments, or however long it takes you to solve this, and solve for our increasing, decreasing, and constant intervals. All right, so step 1, we have to get an f prime. And in this case, that equals, well, x cubed is 3x squared minus, drop the 2 to the front, and that's just going to give us 3x. Step 2, we got to get the criticals. So in our case, does not exist, does not exist. So we're just going to take this and set it equal to 0. So 3x squared minus 3x equals nothing. Okay, we can divide both sides by 3 to get rid of that 3. That'll cancel here, here, and here. So we just have x squared minus x equals 0. We can factor out an x and then set both of these equal to 0. So x equals 0, x minus 1 equals nothing, and 1. So x also equals 1. So we got our criticals. Step 3 is the number line. Alright, so draw a number line and plotter, and we're going to plot our criticals. Line's not straight. That's what happens when you take your eyes off of the line tool. Alright, so let's plot 0 and plot 1. So there, I'm going to star them now. Those are our criticals. Alright, so let's test the number to the left, to this interval. You know, I'm going to write this in a different color. Let me write it in blue. So let's do -1. Let's find one in the middle. Well, let's just go exactly half and go 1/2. And then let's come over here and use 2. Alright, so if we plug in -1 to our interval here, we are going to get -1 squared, which is 1, so that's 3. And then put a -1 in here, that's -3. 3 minus -3 is +3. So that equals a positive number. So for this interval, it's positive. Let's put in 1/2. You plug in 1/2, you get 1/2 squared, which is 1/4, times 3, minus 3 times 1/2. Alright, so here, 3.5, 3 times 1/2 is going to be bigger than 3 times 1/4. So that's going to give us a negative number. Alright, and now let's plug in 2. So we're going to have 3 times 4 minus 3 times 2. Well, 3 times 4 is larger, so that's going to give us a positive number. Alright, plug in your criticals, 0, it's going to give us 0. So that means it's constant. Plug in 1. Again, that's going to give us 0, so it's constant. Alright, so let's write our interval. We are increasing from -infinity to 0, and from 1 to positive infinity. We are decreasing from 0 to 1, and we are constant at 0 and 1. So at x equals 0 and x equals 1. So there you have it. That is increasing and decreasing intervals and how you can use your equation and your derivative. Well, mainly just your derivative. That's how you can use your derivative to tell where a graph is increasing, decreasing, or constant. So you no longer have to graph an equation to figure out the intervals where it's increasing, decreasing, and constant. Alright, so watch this video as many times as you need to understand this concept. There is no ticket in the door, so make sure you understand it when you come to class tomorrow. See you tomorrow.